Welcome back to Physics for the Real World. Well, when we finished last time, I left you with a question. And the question was a bit of a puzzle. It is why astronomers dislike astrologers so much. They have astronomers almost have a devil. In fact, I suppose that every religion needs a devil, and the astronomers have a little religion of their own. And their devil is the astrologers. How does that come to be? Well, there's a lesson, a historical lesson in that, and it relates to science, but not only science, it relates to many things. It turns out that whenever there's a philosophy going, and then that philosophy has a great change of course, at that change of course, then there's the philosophy takes off in a new direction. The philosophy, of course, being a cosmic philosophy, doesn't want to ever admit too much to being in error, and therefore they don't want to tell about the fact that they had to change course, and so they kind of deny their history. Let me give you some examples of that. Of course, the first example is astronomers will of course admit that astronomy originated with astrology, but they don't want to say too much more about it. They don't want to go too deep into it right then and there. That's the end of it. They certainly don't want to say that the driving motivation and principles of astronomy and the driving motivating principles of astrology are one and the same. But I'll give you another example of that. Take Passover. Well, no, let's take Easter. Take Easter. Where does Easter ultimately come from? Easter is a Christian holiday, but where does it come from? Well, it comes from Passover, which is a Jewish holiday. And while that won't be denied by Christians, nonetheless, they don't want to say too much more about it because they have a slightly different view of the world than the Jewish view of the world. And then to say that Easter comes from Passover and to emphasize that would be to go back to the old view of the world that predated the Christian view of the world. Now, if you talk to Jews and ask them where does the idea of Passover come from, they will. I think that all the years I was in Sunday school, not on one occasion, on no occasions at all, not on one occasion did anyone in Sunday school, I went to a Jewish Sunday school, so no one ever mentioned that it came from an ancient pagan pre-Jewish celebration of the spring equinox. And that's how come Passover is celebrated at the time that it's celebrated. It's celebrated because at that time of the year there is the spring equinox. What's the spring equinox? Well, sometime in winter you have the shortest day of the year, and sometime at the beginning of summer you have the longest day of the year. And there is a time halfway between summer and winter, it's called spring, when the days and the nights are exactly equal in length. And I suppose that's why it's called the equinox. And that was an important time of the year. It was recognized by the most ancient people long before even the time of the Jews. And that's how come that was chosen as the time for Passover. So people don't want to admit their history. Now, this not only, of course, it applies to religions, but let me give you some other examples even in physics where it applies. In the olden days, and by the olden days in this case, I mean the days of Galileo, before it was clearly understood that there were two separate things, momentum and kinetic energy, they had the two ideas for momentum and kinetic energy confused. They didn't realize, the people at the time of Galileo did not realize that there were two separate things. And they had one name for it in those days, and they called it impeto. And of course that led to a great deal of confusion because they didn't know if the formula for Impeto should be the formula for momentum or the formula for kinetic energy, and there were all kinds of arguments, and eventually it was realized that there was momentum and kinetic energy, and that resolved it. So what did they do with the idea of Impeto? Instead of telling where the idea of momentum and kinetic energy came from, they deliberately struck Impeto from the dictionary of physics. If you go back into a physics book and you look up the word Impeto in the index, you won't find the word. The word was completely exercised, or what's the right word? Cut out. And that's how they dealt with it. If you think about Impeto, it's very nice to think about it because that throws a light on how the idea of momentum and kinetic energy came to be. I'll tell you about another example in physics where physics denies its history. All the ideas now of field theories and unified field theories originally came from an idea of the ether, which was a 19th and an 18th and 19th century idea. The ether was some imaginary medium that filled the vacuum of space. Of course, the idea for the ether was greatly changed, enormously changed, and changed by the idea of relativity and then changed by the idea of quantum mechanics. But instead of going back and telling where the idea came from, now, of course, if the ether is mentioned at all, the only thing that's mentioned about the ether in a modern physics book is that it does not exist. And some of them, even more modern books, don't even go that far. The word ether doesn't even appear in the index. So you find that all throughout. It's an important lesson, though. If you're trying to really understand a subject, one of the most important things you can do is trace back and see where ideas come from. When I was in high school, and I told my teachers and counselors that I wanted to go on to be a physicist, they told me, well, if you're going to be a physicist, you have to learn German. And I tried and tried and tried, and it was always quite a struggle, it was quite a handicap because I had a very difficult time with it. But later on, after I got into physics, I never found one occasion in all the years, and now I'm 50-something years old, not one occasion when I ever really had to look up anything in German. But something that I found that was very useful was if I could have been told to learn a little Latin rather than a little German, because many of the old names for things in physics are essentially Latin names. And if you understand a little Latin, you can understand how they occurred to the first people that thought about them. You can see what they were thinking if you can translate the old Latin name for something like vis viva or something like that, and see what it means. It'll tell you, it'll reveal the idea that was in the old people's heads. And it turns out that's very useful because the old people who thought about that were thinking about it for the first time. And the student who meets that subject is also thinking about it for the first time. And so it's nice to see how they understand the subject through the eyes of a person beholding it for the first time. And if you can understand a little Latin, that really helps in understanding what these people were thinking in physics, way back in the days of Galileo and Newton. Well, so much for that. Incidentally, I mentioned that physics was like a religion, and while I won't go into it too much, you'll find out that for most every situation in physics, there's an analogous situation in religion, and for almost every situation in religion, you can find an analogous situation in physics. Because it is and that's not surprising, because in their hearts, physicists believe that the view that they have on things is absolutely right. Not the view of things that they've recently discovered and don't understand, but I'm speaking of the view of things like energy, what energy is, and if energy is conserved. The physicists believe that they have the absolute truth on that. And religious people also believe that they have the absolute truth. So it's not at all surprising to see that in many ways they think the same way, speak the same way, and form parallel organizations. Okay, well, let's go on. Now, the subject for today is the old system of the world. That's what I want to talk about today, the old system of the world. If I ask you about how the world is say the modern system of the world, the system of the world that is believed today, that's taught in high school or grammar school, that you see described on the science programs on television, on Nova and whatnot. The idea starts out with the world is made of little tiny things. If we go down, well, let's start it ourselves. And we go down, and we are made of cells, and the cells are made of molecules, and the molecules are made of atoms strung together, and the atoms are made of parts. The atoms have electrons whirling around and a nucleus in the center. And then we go down and we ask, well, what about the nucleus? And the nucleus is made of things called protons and electrons. No, protons and neutrons, not electrons. The electrons are on the outside. And what are the neutrons and the protons made of? They're made of things called quarks. And what are the quarks made of? Well, I don't know, but we're down here in a world already. We're in a world that we have no idea of what we're talking about. At the point that we are now, maybe long before this point, maybe when we got to the level of molecules, even before we got to atoms, maybe when we got to cells, we are speaking of a world about which we have no first-hand knowledge. We are entirely parroting things. We're just parroting things that the teacher told us, or perhaps things that we read in a book or heard someplace. But we're essentially reciting a thing like a person who recites a prayer in Hebrew, but does not really understand Hebrew. Nonetheless, you can imitate the sound. And for important occasions, Jewish boys are taught to say prayers in Hebrew, not understanding a word at all of what they're saying. And many of the people who talk in school about protons and neutrons and the nucleus are essentially parroting something that they have had no first-hand knowledge of, and they don't know how it hangs together. But that's our view of how the world is made. It's an important thing. It's not like some prayer that you say and then you go on. And this is a description of this world, not the next world, this world, because we are supposedly made of these quarks and things. Now, if we go in the other direction and you go out and you say, well, here I am and in this world, and what am I surrounded by? Well, I'm surrounded by the Earth, and then there's the Earth. But then the Earth is not the only planet. There are other planets in the solar system, and we all go around a thing called the sun. And what is the sun? Well, the sun is a star, and if you look into the night sky, you will see many other stars like the sun, only they're so far away that they're much fainter than the sun. And then, can you go on? What happens here? Does these stars go on forever? No, all these stars are gathered together into a flattened, like a great millstone in space, but the millstone is made of many stars, and it spins in space, but it has only a finite size, and then it ends, and you go out into the emptiness of space. But space is not completely empty, because eventually you might come to another one of these great collections of stars, and these things are called the galaxies, and they're out throughout space. And then if you go on beyond there, what do you come to? Are there galaxies forever? Well, then there's all kinds of questions. Or do we run out of galaxies? Or maybe the galaxies are distributed in clusters themselves. Or maybe there is some strange place in space where whole volumes of space are empty of galaxies. Or maybe space is curved in some strange way, so that if you go out into space, somehow you come back in the opposite direction you came, even though you went that way. And things get very, very weird, and it's very hard to understand how this thing works when you get out into the large. So what I point out, in our present view of the world, you don't understand very much. If I ask you, what are the forces that really hold molecules together? I doubt that many people can give a firm answer. You know, there is some force that's holding this piece of chalk together, because if I pull on it, of course, if I pull on it real hard, I'll break it apart. But if I just pull on it mildly, I won't fall apart. What's that force? What is holding it together? So how many forces are there in the world? Maybe you've looked at a science program, or you've read a science book, and you've heard that there's, 4 or 5 forces in the world. There's the force of gravity. Is it the force of gravity that's holding it together? No. Well, there's the force of, is it this nuclear force? Well, the nuclear force only happens in nuclear reactions. This is not a nuclear reaction here. Is it an electric force? Well, that's holding it together. Well, maybe it is. Actually, if you read the book the books will say it's the force of electricity that's holding this thing together. But that's hard to believe, because if you read a little bit further in the books, they will describe the force of electricity, and they will say the force of electricity is between opposite charges. Positive charges attract negative charges, and negative charges attract positive charges. Now, if one side of this chalk was negative and the other side was positive, then there might be some explanation of why it was holding together. But which end is positive and which end is negative? Both ends, to me, seem to have no electricity on them at all. As far as I can tell, they're not electrified. When things are electrified, they make your hair stand up. I don't have much hair, but even if I did have hair, I assure you that putting this chalk above it would not make my hair stand up. So it's really hard to see how the force of electricity can be making this chalk hold together. So the present view of the world that we have, if you look up in a chemistry book and you find that it's somehow electrical force that's making this chalk hold together, that's the present view of the world. The present view of the world that we have is really not very understandable, even if you stop and think about it. Now, maybe if you think a great deal about it, you might be able to ferret it out. But if for a 1 day's thought, or even 1 week's thought, how this world holds together, how it works, either on the large scale or on the small scale, is very, very difficult to understand. And most of what people call understanding, what you see on these science educational television programs, is parroting, is just parroting words. Okay, now, it was not that way in the ancient world. In the ancient system of the world was very understandable. You had to think about it, but you didn't have to think all that hard. And any reasonably intelligent person could understand how the world worked. And what I mean by a reasonably intelligent person, I mean, say, a doctor or a lawyer. Now, if you go to a lawyer and you ask him what makes the atoms hold together, he will tell you he doesn't know, and then he'll give you a $20 bill. Why will he give you a $20 bill? Because I think it's $100 an hour, and he only divides his hour into $20 segments. But in the olden days, a normal person, if you expected that a person would go so far as to be a lawyer, that person would also have some knowledge of how the universe worked. Now, what was the old universe? How did it look? Well, I'm going to describe you the old universe. The old universe was made of 4 elements: earth, air, fire, and water. And you might know that the signs of the zodiac are still divided up into earth signs, air signs, fire signs, and water signs. And how was it? Where did they go? Okay, the old idea of the world was this. You had, in the center of the world was the earth. And there's the earth. And surrounding the earth was another sphere, and that was the sphere of water. And then surrounding the watery sphere was another sphere, the sphere of air. And finally, surrounding that sphere was the sphere of fire. And that was the view of the world. Now, let's ask a few questions about that. Why was it spherical? Well, that's a good question. Why was it spherical? For 2 reasons. There are 2 reasons to understand why the ancient world is spherical. And the first is a scientific reason. If you go out in the country in the evening when the sun is setting, say the sun is already below the horizon, and it's just that time of night when the first stars begin to come out, and you lay down flat on your back on some grass and you look straight up into the dome of the sky, you can actually get the feeling that the heavens are a dome above your head. Many a poet has said that, and it's an easy perspective feeling to get. It has something to do with the physiology of the eye and the brain and how they're hooked together. But you can easily get the feeling that the sky is a dome above your head when the first stars appear. Now, the sky has to fit snugly into the earth. Therefore, if the sky is a dome, you also know that the earth must be a sphere to fit within that dome. There are other technical ways to tell, too, that the earth must be spherical. And the reason is that if you're on one part of the earth, you see certain stars overhead, and then as you walk south, or north, you see different stars come overhead. And the succession at which the stars appear overhead could only be possible if the Earth were a ball. But besides these scientific and these observational ways, I guess observational is the right word I should have chosen there, besides these observational ways of knowing that the Earth had to be spherical, there's another way to know it too. Who made the Earth? God made the Earth. And what is the perfect shape? The perfect shape is a sphere. And God would do nothing less than perfection, therefore the Earth has to be spherical. And since the Earth has to fit into the sky, it has to be spherical too. Everything has to be spherical to fit. So it's nice. You see, there are two reasons. One is that directly an observational reason that Earth certainly is spherical, and the other is a philosophical reason why. Now, the next question you should ask, well, okay, I see that the thing should be spherical, but why should there be discrete spheres of fire, air, water, and earth? Why should they be separated out like that? I know I know they are, but still, why should they be? And the idea, why shouldn't the earth, maybe if the earth and the water mixed, we could just take these two inner spheres and mix them together and call that mud. So you start out with mud, air, and fire. What's wrong with that? Well, the idea that the ancient people had was that there was something called natural place, and that everything knew its natural place. Birds of a feather flock together, which is actually true. I've done experiments with my sister has ducks, and she has chickens, and I've actually mixed them up, and the ducks will go over to one side and the chickens will go over to the other. Same thing is true in schools. The government will pay all kinds of money to bus people, all different kinds of people together, so in school you'll have just the right mixture, whatever's in vogue that the lawyers want for that year, and they'll all be mixed up, but then they go into the lunchroom at lunchtime. And of course, the judges and the lawyers aren't there at lunch, so you can sit down where you want at whatever table. And if you look at how the kids sit in the lunchroom at school, over at one table there will be all the jocks, and they'll be talking jock talk. And then over at another table, there'll be all the nerds with thick glasses. And when I was in school, they would be talking about chess. I imagine now they're talking about computers, but I bet they still have the thick glasses. Maybe they have contacts now, but they're still nerds anyway. And then over at another table, there'll be all the pretty girls will be sitting together having pretty girl talk. What's the point? Birds of a feather flock together. And it was felt that the water had an inborn empathy, that it liked other water and it would go to the water. Like if you bring water down inside of the earth, it doesn't want to be inside the earth. It wants to come up. And if you've ever seen in winter water bubbling up out of a spring, you know that, or out of an artesian well, I've seen things like that. The water just jets up out of the earth. It does not want to be in the earth. It wants to get up outside of the earth. And if you ever bring water high up into the sphere of the air, of course it doesn't want to be up there either. It falls down as rain. The water wants to be in some layer above the earth and below the air. And you can bring it into places where it doesn't want to be, but it will come back. And when I say, what do I mean by an inborn empathy? This is what I mean. The thing has a feeling it wants to be someplace. Now, in the olden days, the main thing that people had a knowledge of what caused motion. Well, what causes the motion of your hand? Suppose your hand, you want it to scratch your head. How do you do it? You don't know about your muscles and the electrical signals that you give. That's all something you learned in a high school biology book. What you do is you will say, I wish my hand would scratch the itch on my head. And lo and behold, it does it without knowing anything about how the nerves and muscles and bones are connected. You will it and it does it. And the feeling was that the water wills itself to be with the other water. Now that's a very important idea, because if you ask how does gravity work, at least never mind the most modern views of gravity, but let's take the Newtonian view of gravity. The Earth somehow has an attraction for the moon, and the moon somehow has an attraction for the Earth. It's like you see something over there and you like it. In fact, the attraction between the Earth and the moon is sort of an inborn, it's really an old-fashioned, almost ancient classical idea that there's something inside of it. It has an attraction, almost like there's an attraction. You see across the floor, you see a pretty girl, and there's a certain amount of attraction. Then she winks at you, and then the attraction is multiplied by 10, but it's inborn. There's no ropes going across the room. There's no field. There's nothing. It's just something, it's inside of you, and maybe it's, or maybe not, it's inside of her. Now that idea of inborn empathy works perfectly well for gravity. So you can apply to gravity really an idea, an ancient idea, an idea that originated back in the times of the Greeks. But I'll show you where it does get into trouble. It does get into trouble this way. The people in those days also thought that friction, like everything else, was due to some inborn empathy of objects. Remember, what does friction do? It wants to make objects that are sliding stop. That's what friction does. And the ancients applied the same idea of inborn empathy to friction. Now there you get in a great deal of trouble, because what stops objects in friction? Is it an inborn empathy? No, it's not an inborn empathy. Friction is due to an outside influence of the outside world. You can minimize friction by oiling a thing. You can kill friction completely by letting the object float in space or float in a superfluid. But the ancients, or not even the ancients, the classical people thought that friction, they didn't appreciate that, and so they had a very hard time with friction. So this inborn empathy, while it's a very useful idea to apply to things like gravity, it's a very misleading idea to apply to things like friction, where the action is clearly outside and can be controlled by outside influences. Okay, good enough. Now, that's why the air got together with the other air and the fire got together with the other fire. Of course, if you take air bubbles, if you take air and put them underwater, what will it do? They will form bubbles, and the bubbles will come up to the air. And of course, fire also wants to join the other fire. Where are all the fires? The natural fires like the sun, moon, and stars, the lightning, and the northern lights. These things are all high up in the sky. Now that doesn't mean we can't have fire down here. I can strike a match and I'll have a fire right down here near the earth. But does the fire want to stay near the earth? No. When I strike a match, the flame jumps upward. Always flames jump upward. Why do flames always jump upward? Because the flame has an empathy that it wants to go back up to the sphere of the sky, high up where the sun and stars are, where the fires belong. It's attracted to go to the other fires, and that's why flames jump upward. You see, it's a very nice view of the world. Now, still, so that explains why these things are clustered together, the earth, water, air, and fire. Still, why is the earth in the center? Why not put the air in the center or the water in the center? Well, there's a reason for that. The earth is in the center for this reason. There's an old expression that potters have, or even people that work with lathes and machine tools, they have, or even people that mount automobile tires, they call something the dead center. Why the dead center? Because whenever you have a thing that spins, the very center of a phonograph record, the center of a potter's wheel, the center of a rotating object stands still, and that's why it's called the dead center. Now, of these various things, which thing wants to move least? Which is hardest to move? Well, heavy things are hard to move. And what's the heaviest thing in the world? The earth itself. The earth wants to move least, therefore the earth goes in the dead center where it moves least. Now, what moves more easily than earth? Well, water does, so it's further out because it has to move around. It can move more easily. Now, what moves even more easily than water? Air. Air moves even more easily than water, so it's out here where it has to do more moving. And there is something, just like the earth wants to stand still. If you make a heavy object move, it will, due to something inside of itself, at least in the view of the ancients, it will, due to something inside of itself, come to a stop. There is something that if you make it stop, it will by itself begin dancing. And what is that? That's a flame, fire. Sure, you can maybe make a fire stand still for a minute, but the minute you let go, the flame will begin dancing. It's perpetually dancing. It must be moving, and that's why the fire is in the outer sphere. So that's the natural order of things. The earth, which wants to move least, is in the center, and the fire, which wants to move most and won't stand still, is in the outer sphere. And in between, you have the in-between things. Okay. Kind of nice. You can almost, it's easy to believe this. Isn't this kind of a nice picture of the world? It is fun to talk about it, and it's easy to believe. And this idea is perpetually revived under fancy names like New Age science, things like that. Okay, now I want to show something else. There are actually different rules for different parts of space. In other words, the same laws of physics do not apply in all parts of space. Let's look at this. Let's look at perpetual motion. If we go up into this fiery sphere, the sphere of the sun and the moon and the stars and planets, these objects all do have perpetual motion. What do I mean by, what I mean by that is each day the sun goes around the sky, the moon goes around the sky, the stars rise and set once every 24 hours. And the planets not only rise and set with the stars, but they have motions within the stars, and they keep on moving. And not only do they keep on moving at the same speed. In other words, the sun goes around in 24 hours, and the next day it doesn't take 28 hours and 29 and 30 hours like an ordinary thing would, slowing down. It keeps on going around at 24 hours. So perpetual motion is possible in heaven. But if we go down to the earth, is perpetual motion possible? No, that's one of the things that they realized early on as a generalization from the principle of the lever. Perpetual motion on the earth is not possible, but perpetual motion in the heavens is. They are different. They're different universes with different rules of physics. Also on the earth, if you set something going, it goes in a straight line. In other words, you roll an object and it will go along the floor in more or less of a straight line. It won't go forever either. It'll come to a stop. But in heaven, what happens to motion? In heaven, nothing goes in a straight line. In heaven, the sun, the moon, the stars, all those things go in circular motion. Sometimes circles compounded with other circles, circles compounded with circles, compounded with circles. But the motion in heaven is not in a straight line. The motion in heaven is in circles. Why is that? Because God makes things move in the perfect curves, and the perfect curve is, of course, a circle, and that's why the laws of motion are different. Okay. Now, I want to show you something else about an important difference between the heaven and the earth. Things in heaven, not only motion is perpetual, but everything is perpetual. If you look at Jupiter, the light of Jupiter never fades, nor does the light of the sun ever fade. The sun is a fire, but the fire burns forever. Now, there are fires on the earth, just like the sun. There are fires on earth, but do fires on earth last forever? They do not. A fire on the earth that goes out, but in heaven it burns forever. Also, if you look at the things in the sky, the things in the sky stay that way. They stay that way forever. Whatever the moon looks like, the full moon, then the next full moon, then the next full moon, the full moons all look the same. But if you make something on the earth, a thing on the earth will not look the same, even if you make a painting of the moon on the earth. And it's a very nice painting. Over the years, the painting fades and deteriorates, and the termites eat it, and probably all kinds of other bugs eat it. Nothing lasts on the earth, but everything lasts in heaven. And there was one exception to that, gold. On the earth, gold seemed to be the one thing that would not rust or rot or deteriorate. And there was a feeling that the people had in the olden days that gold was something, a little piece of the heavens, which has somehow become stuck on the earth. It kind of reminds me of these micrometeorites people occasionally find. They find now these little things on the earth that they say came from heaven or came from an ancient comet or came from the moon. They even find some little specks on the earth that they say fell from Mars. They'll see them with a microscope embedded in the rocks. How they tell, I don't really know, but it kind of reminds me of the attitude that the ancient people had about gold, that it was a little piece of the heavens that fell down onto the earth. Now, I want to tell you another thing, even more basic than this, about the attitude that people had. The things on the earth were made of earthy things, and that meant that they were heavy. Heavy means that they would fall. But the attitude that the ancients had about the things up in heaven was that they had no weight. In fact, they had no inertia. they were just lights. Lights like the lights that you see on a screen. When you see on a movie screen, you know it's not an actor. You know it's just a light and dark projected in the shape of the actor. And that was the attitude that these people had. That these things that you saw in the heavens were not material objects. They were just lights. And in particular, I'll tell you about the moon. You might know that when we see a full moon, you always see the same face of the moon, the old man in the moon or the old woman in the moon or whatever you happen to see. But the face of the moon that is turned towards the earth is always the same face of the moon. And that gave the ancient people the idea that the moon was somehow a window up in the heavens, maybe illuminated from behind or illuminated from in front or had some internal illumination. But it was a window-like object. They did not think of the moon as being another body out there like the earth. Now, that was the majority opinion. Now, undoubtedly, there was minority opinions too with other views, but you can see how that majority opinion got there, because when the moon is full, you always see the same face as you always see the same picture in a stained glass window. If it had turned out that the moon had a little more angular momentum and spun so that the people on the earth could see the moon going around, how different history would have been. I dare say that we would be 1,000 or conceivably 2,000 or 3,000 years ahead of where we are in science, because the old people, it would have been forced on them to realize that the things up there are like the things down here, and they would have come to that realization at least 1,000 and conceivably 3,000 years earlier than they did. And with that realization, science would have developed a lot faster. But the moon always shows one face to the earth, which affirmed people's ideas that it was just a light up there. Okay, that idea, of course, fit with people. The idea that it was a different world up in heaven than it was down on earth gave people, it fit with people's other ideas. It was not, there wasn't scientific ideas over here, and then there's one body of scientific ideas, and then you have one idea of moral ideas, and maybe one body of legal ideas. You know, they have these different bodies of ideas. In fact, I was talking to a student just the other evening who told me how hard it was to introduce scientific ideas into court because of the way the court is set up. It's very hard to bring scientific ideas into a court of law. There's these different worlds. And of course, it's very hard to bring scientific ideas into a moral discussion too. But in the olden days, this was not so. Everything, the view of the world seemed to fit with people's view of how everything else in the world happened. You see, in those days, they thought that since the heavens were a different world, it was very reasonable that God should live up there. Or the gods, however you want it, either singular or plural. And if the gods lived up there and the gods ran the planets, then it's very reasonable that the planets could control us, because certainly we were controlled by the gods and the planets were at the gods' fingertips. So there's every reason to suspect that somehow by watching the planets you could watch the thoughts or the motivation of the gods. And this idea of a hierarchy, that you have different rules in different places, is a familiar idea. Let me start out with something in the olden days, like down in the bottom of the world. Who's down in the pit? Well, a poor man, probably a peasant. A man is down at the bottom. And then you go up a little bit higher in the hierarchy of the world, and what will you find? You might find a priest. Hope I spelled that right. That could be either an ancient priest or a priest of the Middle Ages. And then if you come up above the priest, what are you going to find that's more powerful than a priest? Well, up here you'll find a saint. This is something that's not quite a god, but it's certainly, a saint is above an ordinary human being, and a priest is at best an ordinary human being. And who is above a saint? Well, you can get to an angel. And who is above an angel? An angel is certainly not a human being ever, but there is still something higher up above you can get to God. So there's a hierarchy going up. In the same way that there's a hierarchy going up here. The man at the bottom on the earth, and then above you get different rules, and finally you get to the world of the gods. Even today, you see that same structure in things. If you ever work in the corporate world, you'll see on the very top of the down at the bottom, there's the ordinary, there's the worker. And then who's above the worker? There's the straw boss. And who's above the straw boss? Then there's a man called middle management. Middle management man. And then who's above him? Well, there's someplace, above him, say, is the president. But even the president is not the highest, because the president can be fired. The president can be fired by the chairman of the board. Isn't that right? So there is that hierarchy, and they live in different worlds. For a long time, I worked for the Chrysler Space Division. That's the division of the Chrysler Motor Company that made the Saturn spacecraft, the Saturn booster, I should say. The Saturn booster is the booster that lifted Apollo on the way to the moon. And that rocket was put together by the Chrysler Corporation. The first stage was put together by the Chrysler Corporation in New Orleans, Louisiana. And one of my jobs at one time was working for them, thinking about payloads, things that would go on top of the rocket. Of course, the idea was if you could have more nice things to go on the top of the rocket, then you could sell more rockets, which was a good idea. And the things I thought about were telescopes. We were thinking about space telescopes way back in the early 60s. It's interesting that it was the 1990s, and they still don't have a working space telescope, but we were planning them in the early 1960s. Well, anyway, naturally we had a lot of ideas. And if I went to my immediate boss, of course, he was a friend of mine, but nonetheless, if I went to my immediate boss at Chrysler and told him about something and he was busy, he would say, "Lou, get the hell out of my office." And maybe he would throw something at me if he could. And he was a guy that sat behind a steel desk. You know, he didn't have a nice wooden desk. He sat behind a steel desk just like I did. And maybe he had a secretary, maybe he didn't. But that was the world he lived in. He was down here. But then sometimes I would have occasion to go to talk to the president of the space division. He was way up here. And he lived in a different world. He lived in a different world. First, you'd go up the elevator to his place. When you got out of the elevator, the first thing you noticed was there was a rug on the floor. Not only was there a rug on the floor, you went to see a secretary to talk to him. And she was a very good-looking lady. Not only that, on her desk, she had a little vase with a rose in it. The secretaries down here didn't have roses on their desk, but up here they had a little rose on his desk. And then very shortly I would be ushered into his office, and unlike my straw boss, he would be very polite to me, and he would say, "Hi, Louis Epstein, what have you got to say today?" And I would give him my idea. And very often he would not go along with it, but he'd say, "Now that's a very good idea, Lou, but I don't think we can implement it right away. But nonetheless, why don't you come to lunch with me?" And he would take me to the executive lunchroom, whereas my boss would just throw something at me when I went into his office. So the point I'm trying to make is these people up here live in a different world. And of course, that's nothing new. That it was that way in the days of the Greeks and the Romans too. And it seemed entirely to fit the view, the cosmology, fit the religion, and fit the economic structure, that there were different rules. Of course, we can have the political structure up here too, with starting on the bottom with a peasant, and then some sort of a local knight, and then going on up here to a duke, an archduke, and a king, and whatnot. We could show that there's this structure fits throughout the world. So that was the ancient view of the world, and it was a very nice, understandable view of the world. And then all of a sudden, there came a guy about 500 years ago called Copernicus, Nicholas Copernicus. And he said that the world was not this way at all. He said that this was all wrong. And the earth was not in the center of the world. And he said that it was the sun, one of the fires, that was in the center of the world. That's what he said. By the way, I have a little puzzle for you. That reminds me. Some of you will say that all the fire is not really up here. The ancients had one other thought. There's a little fire where? down in the center of the earth. Isn't that right? And of course, that fire has to do with the place that you don't want to go to. But I'm going to tell you about that. You can tell there's a philosophical way to tell that's not appropriate. Something's wrong with that. So you can tell that it's the work of the devil. And maybe you can see for yourself. I'll bring that up next time. I'll give you a little puzzle about how did the ancients explain that fire in the center of the world, which shouldn't be there. But now I'm ready to cross this out. And we'll go back, and I'll tell you about the sun. This guy called Copernicus that lived 500 years ago, he says, it isn't this way at all. He said the sun is in the middle of the world, and he said the planets go around the sun, and in fact the Earth is just nothing but one of the planets. In fact, it's not even a special planet. You might think it would be the planet that's furthest from the sun or the planet that's nearest from the sun. But there are planets that are nearer the sun than the Earth and planets that are further than the sun than the Earth. And where in the hell did this guy, how did he get this idea? It's such a crazy thing. The Earth moves. Of course, I know they told you in school the Earth moves. They tell you on the science programs on television that the Earth moves. Have you ever moved in your life? When do you move? You move when you're in a car. When you're in a car, do you know which way you're going? I hope you know which way you're going when you're in a car. When you're on a bicycle, do you know which way you're going? Yeah, you know which way you're going. Even when you're in an airplane, you look out, you can tell which way you're going. Now, if the Earth is moving, as you parrot, as you're taught in school, then tell me, which way are you moving? I'm on the Earth right now. Am I moving that way, or am I moving that way? Or maybe I'm moving that way, or that way, or this way, or that way. Which way am I moving? This guy Copernicus got the idea that you're moving when you can tell perfectly well you're not moving. Where did he get this idea from? What was he smoking? What got into his head? Well, when next we get together, I'm going to tell you the story about Copernicus and how he got the idea that the sun was in the center of the world and that the Earth was just a planet like the other planets moving around, which is awful hard to believe. Next time, I'll tell you about that.